Welcome everyone to this webinar. So I'm Emmanuel. I'm the Kubernetes product manager here at Scaleway. And today I wanted to talk about security and Kubernetes, which are obviously two of the simplest topics you can talk about. Um, so what's going to happen? I will do a short introduction to present Scaleway and talk about how all that is going to work. And then I will go from the cloud part of the Kubernetes cluster and dig down to the code and the data parts. So the idea is to secure every level of what you can manage within your Kubernetes cluster. And at the end, well, I have some personal advices in the security cheat sheet. So yeah, if you're bored, you can go back directly to that. I hope you won't be. Okay, so let's go. First, a few words about Scaleway. So Scaleway, we have three specialized brands. We have first Scaleway Data Center, which is obviously the infrastructure. So, if you don't know about the cloud, you probably suppose that we need to host it somewhere. So that's for the data center. We have Scaleway Dedibox, which are our dedicated server. And at the end, we have Scaleway Elements. So Scaleway Elements, it's all the cloud part. So it's what we call our public cloud ecosystem. And obviously, as someone working with Kubernetes, well, I'm going to talk more about Scaleway Elements. So it's divided, let's say, into different main categories. You have the compute part with all the instances you probably run your services on, and also your Kubernetes clusters. We have storage as databases as a service, or even as remote storage, like block storage. Uh, Obviously, network solutions, because if you don't have network, well, you don't have anything. And we also have some other topics, which is more on the R&D side. So on the AI and IoT, so the IoT, you already have a product that is available, and you can connect objects directly, like manage a fleet of remote objects together. And in the middle of that, what we call the steering is all the tool that we provide to, well, just use all those services. And well, obviously, since we're talking about Kubernetes, I have to tell just a bit about Kubernetes Kapsule, so which is our managed Kubernetes engine. We are kind of proud of it because, well, people have very, very good review from it. So it's kind of nice. And really, we just try to make it as simple to use as possible. It's an availability service. It's fully managed, and it's always up to date to the last Kubernetes version that's available. You can see that the team, like just in a few days after a version is released, it's up. So if you want to get in touch with the team, well, there is a Slack community channel where you can talk to them and to all our community. We have almost 700 users in that channel right now. So just come and make that number go up. And so you can talk to Ben, Jeremy, and, well, Shade, which is Patrick. Obviously, the last one, it's me. But the other will help you more. Okay, so if we go just quickly over different topic that I'm going to talk about, the main idea I want to focus on is that everybody should care about security. Whoever you are, whatever your job position is, you should care, because at the end, it's your company's service that are at stake and your customers' data. So, well, it's really your business. So everyone should care. Of course, I'll try to provide solutions and options so you can, well, learn and dig deeper to what solutions are the most um, reliable for you. And I'll try to say each time who should be the most careful about some of those elements. So I'll do that with the little cards. So here I have 5 different imaginary characters that voluntarily don't have specific jobs. You need to just pick one card and say, okay, that looks like more what is my job description. If you're usually the one who pays a check at the end of the month, maybe you're the boss. If you're dealing with data, you might be uh, more the analyst guy, architect, more about the infrastructure, maybe a DevOps, maybe an system administrator, obviously developer, and, well, the end user, because at the end, we do that for our users, right? And I hope that at the end of that webinar, well, you'll feel a little more responsible about security, whatever your role is, and that you will have enough tools to address it. So we are going to cover a lot of topics. So I won't go into the details of everything because, well, I don't have the time. But I'll try to cover all the different part that you need to focus on. It can be about code directly, third parties, so product that you use outside of your real value that you add. It can be about the CICD and the cluster, the Kubernetes cluster itself. So you're probably wondering, how bad can this really be? Like, do I really need to secure my clusters that much? So I ran a test on one of my clusters, and it was pretty bad. So 63 issues. What was on that cluster? Just tutorials straight off the internet. A GitLab project of mine. I have to say that I haven't maintained it for a while, but still, more than 1,000 vulnerabilities on this project. And, well, on-the-shelf apps that are installed using help. So pretty straightforward stuff, just put out here in my cluster. And as you can see, well, it did not go well. So yeah, maybe there is a few things we need to focus on. So those different topics are the one that I'm going to talk about. I'm going to talk about security policies, network policies, packages, data encryption, all that kind of thing. So we'll start then by securing the cluster itself. So it will be really the root of the cluster. Just so we know what we're talking about and that we have the same language, I have a quick, very simple scheme. So as you might know, if you're already using a Kubernetes cluster, you have different parts in those clusters. You have the control plane, which are usually, well, which are the master nodes when you're using a managed Kubernetes engine. That's something we manage for you. And you have the worker nodes. That's something on your side, that the nodes that you're using, for instance, it's the dev or GP or even GPU instances that you can use as Scaleway within your Kubernetes cluster. And you have the etcd database, which is a key value store where all the data of what Kubernetes objects are stored in your clusters. Well, those data, they are in the etcd that you don't have to manage also if you're using a managed Kubernetes engine such as Kapsule. And within the workers, you can define namespaces and you have pods. For those who are not familiar with pods, but more with containers and Docker images, you can consider it as a first layer of abstraction on it. But that's pretty much it. It's just to make it a little more complicated, right? So the first thing about your cluster is that you need to log to it. Okay, you need to connect to it. And how do you do that? You do that through certificates. And you have two options there. Either you manage your Kubernetes cluster yourself, or you use a managed Kubernetes engine. So in one case, you have to generate your certificates. You have to protect them, of course. And you need to think about the process of life of your certificates. Because, well, what happens when someone leaves your company with the certificates? How do you do to renew them? That's some stuff that needs to be taken into account when you're choosing your solution with Kubernetes. And you need also to ask yourself that question when you use a managed Kubernetes engine, because all cloud providers don't manage it the same way. The first really more complex object that you're going to define would be admission controllers. So admission controllers would be like a filter on your control plane. You will add filters, so there will be conditions for requests to be accepted or denied by your cluster. That can be about a lot of things. You have a lot of different strategies that you can choose from. And here I chose to list 8 of them. I'm not going to go through the detail. I'm just going to, well, pick 1 or 2 here and there. So admission controllers, they can be about defining a storage class. They can be about setting limits to what resources are allowed for a process that is running within your cluster. They can be forcing you to use some authentication methods. They can force you, like the always pull image, to say that every time you have a new pod, well, you always pull back the image from the registry you're using. That forces you to only use valid credentials always, and that your image is always the last one that you pushed. And there is the pod security policy, which I will go back to a bit later. From all those 8 admission controllers, 7 of them are defined by default in Kubernetes Kapsule. So when you create a cluster, you already have some of those layers of security that are set, but not the pod security policy. And we'll go back to that a bit later. Also, when you manage it yourself, well, think about setting admission controllers. And if you're using a managed Kubernetes engine, well, look at what the provider is setting without you knowing. So before talking about the pod security policies, uh, we'll talk about another policy that is more on the network side. So it's called network policies, obviously. And you have to know that by default, pods, so what you deploy on your clusters, are not isolated. So they accept traffic from pretty much everywhere. So they can be reached from outside our cluster, inside our cluster. It's kind of, yeah. So what you can do is define network policies. That's a way to isolate your pods, defining some rules that you can just add them. And you can just define that a set of pod will have some egress or ingress rules. This way you can control the traffic, say that you can allow some IP address to call a service or just forbid it. Now, if I go back to pod security policies, that's a bit trickier. So it's a layer down in the cluster. You have the possibility to define rules to accept or reject the creation of pods. The reason why it's not set by default is that if we set it by default in a managed Kubernetes engine, well, a beginner, let's say, that will want to try Kubernetes and deploy his first application, well, he wouldn't be allowed to do it because you have to define other objects, pod security policies objects, if you have that admission controller set. So it's kind of, if we put that here, all the users that doesn't know about pod security policies, well, they really can't do anything. So that would be annoying for a cloud provider. And yeah, you can really decide what is allowed to run and what isn't in your cluster. So you have very detailed privileges that you can put on that. And of course, you also can set users and group of users and define the authorization on pods, on Kubernetes objects, using Airbag, so role-based access control. And well, that simply means that some users will be able to call a service and some won't. So I'm going to drink a bit. Okay, so that was the big part. That was about securing the cloud. There's a lot of objects here, Kubernetes specific objects, and as everything in Kubernetes, it always ends up in YAML files, as you probably know if you already touched it. But at the end, it's really important that the root of your cluster, the entry point of your cluster, is defined by some rules. And well, once that cluster is secured, you're saying, okay, so maybe we can go deeper into what we actually do, like coding. But not yet, not quite yet. So did you think about all the accesses that you need to your cluster while you were defining the admission controllers and such? Like, did you think that you probably thought about your end users, maybe your internal users with specific rules of access, probably maybe analysts that have access to some stuff and not everything. But what about your CICD, your container registry, everything that is connected to your cluster through an access right? And, well, is it secured? So I have a bit of an example with that. Uh, there is a story about last year, um, a company that I know, they were using, well, they still use it, but they were using a CICD, that is managed as software as a service. So to allow your CI/CD to connect to your production environment, which wasn't Kubernetes, but the idea is the same. So they need to give a certificate, a token to the CI/CD to connect it. So the production environment was on Amazon Web Service. And last year, their CI/CD provider was attacked. It was breached. So they sent a mail to all their customers saying, we've been breached. You should change your um, your certificates. You should change the access that you're using to connect to your production environment because maybe it has leaked somewhere. So, well, you receive that. What do you do? Obviously, you generate a new certificate on your Amazon Web Service account and you put it in your new CI/CD. You moved it from here, and whew, you feel safer, right? Except that 2 months ago, it ended up with a $12,000 bill invoice from Amazon Web Service after only 4 days of breach. But how? Because that leaked certificate, well, it wasn't removed from the Amazon account. So it was still out there, unsecured, and the attackers could access to the Amazon Web Service account, and they just mined Bitcoin for 4 days. And yeah, the one paying the bill wasn't very happy on that. But yeah, let's say that we are safe with our CI/CD. Let's say that everything is fine. Though we have a lot of restrictions set, we have a lot of users, we have a lot of, we feel secure, right? And now we code. And while we code, we are using, well, libraries, dependencies, because we are not going to recode everything, right? And remember my old GitHub project with 1,000 more vulnerabilities on packages? Well, that's thing that we should always think about when we develop something and with code is how often do we update our packages or dependencies? How often should we do it? And when something is not, well, when something needs to be replaced, becomes deprecated, what is our policy here? Do we change what we're using? Or do we stuck with those version and say, well, it's fine. I'm sure there is no security breach here. So that's things that we need to take into account when you actually code. So security should not be seen as a constraint, but just as an opportunity to learn, improve, and we should be willing to do it by default. It will never be a waste of time. Your customers will always prefer to have a secure environment, to know that their data, whatever they're using, the service that you provide is safe to use, even if it means that maybe a feature won't be here right now. And of course, it feels like you're stuck into a set of rules that you have to fit into, but you should use that as um, a design constraint, like a way to sync your application in a secured way, a way to design and build your architecture of software. And of course, since you don't want to code everything by yourself, you're using third parties, right? Well, you can use, well, at some time I used Kibana, Elasticsearch, Cassandra, all that kind of technology. And well, of course, you're not going to rebuild everything. I mean, it's here, so you might as well use it, right? And well, it's known, it's maintained, there is a community with it, so it's safe. Is it? Well, that depends. The thing is, like, they're coded by human, like everyone, so they probably has vulnerabilities somewhere. And we can't do much about that, but we can at least look at what we use to really use it well, uh, to really need it. And well, is it secured? Because, well, when you take an application off the shelf, you don't really know how it was built. So you're running it within your cluster. You might as well define security policies, pods, and network policies around it. Isolate them if needed. Use user access rights to know that only the user that needs it access it. Like uh, for instance, if you have um, data application that is used only for, well, the analyst or the data scientist or whoever, well, maybe just he needs to access it. Maybe the other company doesn't need to, and the external users definitely don't. And um, the last security breach I had on the third parties, it was on a Redis database. So we used it for caching, of course. And what happened was that, well, it was not protected enough. It was okay because it's not like it was very, very important data here. It was caching, so it was not uh, mandatory data. Okay, it could be rebuilt. It didn't really matter that much. But anyhow, we still lost all the data in that Redis database because it wasn't secured enough on our production environment. And we have a very nice hacker because it deleted everything and just inserted one information in there saying something like, hey, hi, you should be a bit more careful, because obviously since he was in there, after that he had access to everything, but he didn't touch the rest. So, but sometimes you don't have nice hackers. Just a bit of advice on that. And well, you have secured your cluster, you have secured your code, you are sure that your tools and third parties that you're using are safe or safer than they usually are. So what about your data? You have usually three kinds of data. You have software data, so that's one that you need for your service software, what you provide your customer to run. So usually it can be static, it can be whatever. You have user data. That's sensible data. That's personal information. That's maybe bank accounts, addresses, names, phones number. So that's really specific kind of data, and you have analytics, on which you're maybe using machine learning algorithm, you're making statistics. Um, well, and maybe that is what adds some value to your software and what you do. And all this kind of data, well, usually they require different kind of storage. So you can choose to store data on a Kubernetes environment. That's something that you can do. It exists. But I don't know a lot of people that would recommend it. Why? We consider Kubernetes as a stateless environment. So when you have, let's say, a Kubernetes capsule cluster, well, you have a few features like auto healing or auto scaling that you want to use. Like if an instance has an issue, well, it's replaced and you don't do anything and you don't have to care about what your infrastructure looks like, which is kind of developer dream. And you can also you can also have the auto scaling. So the auto scaling, the idea is that, well, you need more resource, so you allow your cluster to get bigger and smaller when you don't need those resources anymore. So the instances, they can come and go. Like, they are not here forever in your cluster. So if you're going to store something, you should not do it locally, right? Because, well, if it's local to your instance, it will just disappear at some point. That's why we say that usually a Kubernetes environment is stateless. Though you can make it stateful by using Kubernetes objects like block storage, which is kind of, if you plug an external hardware, hard drive, to your instances. And this way you define Kubernetes objects, which are persistent volumes, and you can just store data on it. Even though you can do it, it's still not recommended. Managing a database yourself is something that is difficult, and it's not like, well, using a database as a service. You will never have the same performances, the same reliability. You will not be highly available with it. So it will never be the same. That can be a choice that you do for some of your data if you consider that they are not maybe crucial. But, well, that's something that we could not recommend. But at least if you're using data storage within Kubernetes, you can encrypt it. And by encrypting your data, that's another layer of security that you can add. There is another subject that I care a lot about because I used to work a lot with data, is the legal part of it. That you probably heard about the GDPR that we have in Europe, and it's coming to Brazil with the LGPD there, and it's probably gonna come all over the world. So those laws, they restrict the usage you can do of data. They force you to anonymize, they force you to remove the data if a user asks you to. And that shows some difficulties, right? Because when you're building a service, when you're building something, you're an artist, you're a developer artist, and you want to make something out of those beautiful data. And you just discover stuff and you want to, well, to get value from those data. And imagine that tomorrow, if you built a machine learning algorithm that you trained, and just imagine that half of your data has to be removed and that you have to retrain all your model. For now, it's kind of a blurry zone. It's not defined, but maybe, we don't know, maybe at some point it will evolve in this way. And this could be very, very um, difficult for some software and businesses. So the best advice that I can give on, well, how to manage data is just to ensure that it's safe, anonymous when you can, obviously, and legitimate. You always have to justify every data that you keep and that you use and why you use it. If you're not using it, or if it's not justified, don't keep it. Just don't. So I hope nobody's sleeping. If so, you can wake up. And yeah, some last advices about everything that I just said. Choose wisely, no pun intended. So your certificates, think about them when you choose your cloud provider. Your third parties also. Uh, think about who needs what when you build your softwares and your applications and whatever your business is. Start with a clean environment, because defining security rules afterwards when you already have something in production is way harder, because you won't be able to detect easily what is defined and what has been forgotten. And just feel responsible, because a protection environment, it's the responsibility of everyone in the company. So you're supposed to be all on the same boat. So when things get complicated, when help each other and you learn from it. So basically, I guess that's the conclusion that I like, is that an engaged team makes a protected customer. Um, I hope some of you get that reference. So, are we safe now? We should be safer than most production environments. To be honest, who really cared about security when you code? Uh, a lot of people don't really look at it because it seems complicated. And I have to say, it kind of is. In Kubernetes, everything is YAML files, and you have tons of them, and every new layer of security is just another, well, YAML file. So I wouldn't say it's easy, but I would say it's crucial for your business. So I put there all the different links to the official Kubernetes documentation about the different objects that I talked about. If you have any specific question, specific use case, if you want to use Kubernetes Kapsule and you have some questions, just join us on the Scaleway community Slack. We have a channel, Kubernetes, with all the team, and well, they will be very, very pleased to help you if they can. And well, if they are not there, well, we have quite a large community, so I'm sure someone will reach out. And for last word, um, I would just relate to when I was a developer, and we were counting the code coverage of the uh, unit testing on our code. And well, it's easy to reach 80% of code coverage. You can reach 90%, but at some point you have to stop, right? Because you spend so much time on those tests, trying to have the last line of code into the right conditions just to test it and to reach the 100%, that that is the part that is not worth it. I would say that security is a bit about the same. You should have something secured, but if something is really not that important and is very complicated to do, just don't overthink it. Yeah, and I think I'm done.